Today we're going to be looking at integration as the reverse of differentiation. So, previously we've been doing differentiation, and for a function y of the form x to the power n, we have dy by dx is n x to the n minus 1. So let's consider a function. Let's consider a few functions. Let's consider y equal to x cubed minus 7. The derivative of this would be 3x. Let's now consider y equal to x cubed plus 4. Well, the derivative is the same. What about y equals x cubed minus 59? Again, it's the same. Y equals x cubed plus a half. The derivative is the same. Y equals x cubed minus 0.1. The derivative again is 3x. And y equals just plain old x cubed. Well, it's 3x squared. The point is, we can have an infinite number of functions that have the derivative 3x squared. Any function that we have y equals x cubed plus any number here is going to give us the derivative 3x squared. Tuck that away and just bear it in mind as we continue. What we're going to be learning in this chapter is, if we have a derivative dy by dx, we want to obtain the function y. This is the reverse process. And it's known as anti-differentiation. Now, later on we're going to be looking at a seemingly unrelated problem is, if we have some function, let's just draw some function here, we can find the area under this graph. So say we wanted to find out what area is under here. Well, the process to find the area under a function is known as integration. Now, Isaac Newton, as in the laws of motion, Isaac Newton, and another mathematician, a German mathematician called Leibniz, independently of each other, both discovered that integration and anti-differentiation are the same thing. And this is known as the fundamental theorem of calculus. From now on, we don't talk about anti-differentiation, we talk about integration. So this shows us, if we have this function y, we would be able to, if we differentiate this function, we can find the gradient at different points. But if we integrate the function, we can find the area under it. And this has so many powerful applications throughout mathematics. Now, if dy by dx equals x to the power n, then y is 1 over n plus 1, x to the n plus 1, plus c, where c is a constant. Now if you remember how we had this previously, where we had the derivative was of these functions was all 3x squared, and so we came to the conclusion that any function of this type would have the derivative 3x squared. What we have here is this constant, because when we take our derivative and we bring it back to its original form, we don't know what this constant is, because when we differentiate c, it is removed from the derivative. So when we come back to the original function, we have to add c, some constant, and later we'll find out how we can find what c is for that function. We can also think of f dashed of x, remember our other notation for the derivative. If that's x to the power n, then f of x is 1 over n plus 1, x to the n plus 1, and again plus c. Now, we have a special symbol. This symbol here, which looks like an elongated S, is the symbol to denote integration. So when we're talking about integration, we don't write it out like this. We use the symbol, the integral symbol. So this is called the integral. So say we want the integral of x cubed dx. So we would then, n's 3, so we do 1 over 3 plus 1, which is 4, and then it's going to be x to the 4 plus c. We call this the indefinite integral with respect to x. We call it indefinite because there's infinitely many solutions. We don't know what c is. When we talk about the indefinite integral, we haven't got a value for c. So for this there's an infinite number of solutions because there's an infinite number of values that c can take. Later we'll find out what the definite integral is, and that's when we find the value for c. So in general, the integral of x to the n dx is equal to 1 over n plus 1 x to the n plus 1 plus c, where c is a constant and n is not equal to minus 1, because if n is equal to minus 1, that would then be 0, and that wouldn't work. Just like we had with differentiation, there's a few rules. So if we have an integral of a function that's multiplied by a constant, then we can take k out and we just integrate f of x dx. Also, if we have the integral of two functions either added or taken away from each other, then that's the same as saying the integral of f of x dx plus or minus the integral of gx dx. So let's look at a few examples. So find y in terms of x for the following. Dy by dx is x cubed, so y will be 1 over 3 plus 1, x to the 3 plus 1 plus c, so that's going to be a quarter, x to the power 4 plus c. If dy by dx equals 1 over x squared, then that's same as saying x to the minus 2. Y is going to be 1 over minus 2 plus 1, x to the minus 2 plus 1 plus c. So that's going to be, that'll come out as minus, that's going to be minus 1. 1 divided by minus 1 is going to be minus 1. X to the minus 1 plus c, or write it like this. And finally, dy by dx equal to x multiplied by the square root of x. So we can, going by indices, that would be a half, and we can 1 add a half is going to be x to the power 3 over 2. So y is 1 over 3 over 2 plus 1, x to the 3 over 2 plus 1 plus c. So that's going to give us 1 over 5 over 2, x to the 5 over 2 plus c. Tidying all that up, we'll have 2/5 x to the 5 over 2 plus c. Find f of x in terms of x for the following. So if f dashed of x equals 4x cubed minus 2 over x squared plus 4, so first we're going to rewrite this as 4x cubed minus 2x to the minus 2 plus 4. Then f of x is going to be 4 over, now 3 plus 1 is 4, x to the 4 minus 2 over minus 2 plus 1, x to the minus 2 plus 1 plus 4, x to the 1 plus c. So it's going to be x to the 4 plus, so minus 2 plus 1 is minus 1, so that's just going to end up being, and 2 minuses cancel, it's going to be 2, x to the minus 1 plus 4x to the 1 plus c, and we'll just write that with 2 over x plus 4x plus c. I'll get a new sheet for this one. So if f dashed of x equals 8x squared minus 1 over 2x to the power 4 plus 2x, so that's the same as 8x squared. So the first step is to put the function into a form that we can then integrate. So that'd be a half x to the minus 4 plus 2x. So therefore f of x is going to be 8 over 3x cubed minus a half, that's going to be minus 4 plus 1 is that's going to be a positive, so it's going to be a third x to the minus 3 plus 2x squared plus c. And so we'll just tidy this up. 8 over 3x cubed plus, it's going to be a sixth, and we'll bring this down, x cubed plus, well, it's going to, I've got to bring the 2 down here, so that would be, 2 over there, so that's just going to be x squared plus c. And this one is f dashed of x is equal to x plus 3 x minus 1 all over the square root of x. So this one is a bit more involved, because first we're going to have to expand the bracket, so we'll have x squared plus 3x minus x is 2x minus 3, and that's still over this square root of x. Then we're going to bring 2 plus 2x minus 3, and then we're going to multiply through by x to the minus half. So that will give us x to the 3 over 2 plus 2x to the half minus 3x to the minus half. So now we can start to find f of x. So 3 over 2 plus 1 is going to give us 5 over 2. It's the 5 over 2 plus a half. Half plus a half is going to be 3 over 2, x to the 3 over 2, minus 3, minus a half, add 1 is going to give us positive a half, x to the half, and our plus c. Now tidying all that up, we'll get 2 over 5, x to the 5 over 2, plus 4 over 3, x to the 3 over 2, minus 6 square root of x plus c. And finally we'll do some with the integral sign. So find the integral of x to 2x minus 1 x squared plus 3 dx. Now I would do this in parts so we don't mess up with any x's, as you're going to have to break this out, expand the brackets. So first I would expand this. It's wise just to take your time so you don't make any silly mistakes. So I would just take this out and do it as a wee aside, just to keep myself right. So that's going to be 4x squared plus 6x minus 2x minus 3. So that's 4x squared plus 4x minus 3. And then you're going to expand, multiply that by x. So that's going to give us 4x cubed plus 4x squared minus 3x. So that's what we're going to then integrate. Dx. So that's going to be 3 add 1 is 4, so it's 4 over 4 x to the power 4 plus 4 over 3 x cubed minus 3 over 2 x squared, and then our constant term. Al-Rabi and just tidy this up. And now we're going to integrate 4x squared minus 3 square root of x over x dx. Now again, we want to expand all this out, so we're going to do, and we'll multiply through by x to the minus 1. So that's going to give us 4x minus 3x to the minus a half. So 4x minus 3x to the minus a half dx. So that's going to be 4x squared over 2 minus a half plus 1 is positive a half. So that's going to be 3 over half x to the half plus c. So that's going to be 2x squared. 3 divided by a half is going to be 6. And that's the square root of x plus c. So I hope that helps.